Okay, in this video, we're going through a test review at day number 2 on solutions, acid, base, and pH review to get us ready for our test. The first section is acid-base properties. So circle all the acidic properties from below. So yes, they conduct electricity, they have a sour taste, they turn litmus red, and they have an H in front, which just means it would be H and then some other anion behind it. If you were famous, what would it be for? Maybe you can answer that at home. So now circle all the basic properties listed below. So it would turn litmus blue. It also conducts. It would have a bitter taste. It would have an OH at the end, meaning that we would have some cation and then OH there. So decide whether it be an acid or base by the statement or photo given. You have a green solution. Instead of tasting it, you put litmus in it. The litmus turns blue, so then it means that it would be a base for it. You grab a smoothie and it is super sour. What would it be classified as? Good. If it's sour and most fruit is acidic for it. Now, section 2, we're naming acids and bases. So circle our bases. So remember the signature ion for our bases is an OH. So it would be NaOH and KOH for it. If you panic, notice that these have H's in front. And we would see that there's no OH or H in NaCl. Naming bases, what is the name for this one? Now the 2 behind it just lets us know it's in group 2 and it does nothing for the name. So we just have to name Mg first, which is magnesium. And then we'll see that OH is going to be hydroxide. So naming this base, it would be magnesium hydroxide. Now, what is the formula for this one? So we need to translate lithium, which we see lithium's in group number 1. So we'll see we just need one hydroxide. So lithium is Li, hydroxide is OH for it. Circle all the binary acids. So remember, to be a binary, like a bicycle has 2 wheels, we're going to have 2 elements. So as soon as we see more than 2, we have 1, 2, and 3. It's not that. We have 1 and 2, it is that. We have 1 and 2, it is that. We have 1, 2, and 3, it is not that. So these 2 would be binary because they only have 2 elements. Now, ternary is like tertiary, aka 3 elements, or sometimes we call them oxyacids because they have oxygen in them. So it can't be that. That's 1, 2. That's a binary. We have 1, 2, 3 with an oxygen. It is this one. And then we have 1, 2. This would also be binary. And we have 1, 2, 3 with an oxygen. It would be an oxyacid. Now, if we're naming our binary ones, we have a very specific formula. We're going to name it as hydro, whatever its stem is, and then ic. Don't forget its last name of acid. So if we see H3P, 3 just knows that we need to balance it out. But since it's binary, aka 1, 2 elements, we're going to have hydro. And then if we look for the stem of anything that has P in it, its stem is phosphor. So that's where we're going to put it here. So we're going to see hydrophosphor, and then its ending is ic. Don't forget its last name of acid. Okay, give the formula for this one. So we see hydro. As soon as we see the prefix hydro, it lets us know that it's binary, aka 2 elements. So we're going to have HBr for it. Okay, so what ending would be for our polyatomics? So if you ate too much, 8 will go to ic. So if we had to name this one, it would be nitric acid. If we unite, we're uniting us. So instead of chlorite, it would be chlorus, and then its last name of acid. So let's try some. We have H3PO3. So when we're looking at these ones, we're going to see ternary, there is no hydro prefix, meaning that we need to find PO3. And when we find PO3, we see it's phosphite. The ite lets us know we're going to change it to OUS, but then we just have to correct the stem from phospho to phosphorus and then add acid at the end. Now, if we had to give the formula for this, we see acetic acid. Because there's no hydro prefix, we know we need to go to our polyatomic, and we know that 8 goes to ic. So we see C2H3O2, and remember that this charge tells us how many hydrogens, so we would see it as H, C2H3O2 for it. Okay, section 3 is on pH. So circle all of them that fit for a base. Not a pH of 2, it turns litmus blue. It has a higher number than 7, and it could be drain cleaner, pH of 8, and it turns the indicator teal. Remember, bases are blue, and they're in our BIV, blue, indigo, and violet range for our universal. So, circle the substance that fit for an acid, we would see yes, it's a pH of 2 because it's less than 7. We would see that it turns the universal indicator orange because remember it's at the beginning of our rainbow, our ROY, our red, orange, and yellow. We would also see that it turns litmus red for it. Now, our final section is more about molarity and dilution, so you'll see this solutions part come more with our Kahoot review the next day. So molarity is equal to our moles divided by our liters of solution. So what is big M, our molarity, for one that has 14 liters and 115 moles? So we will need a calculator out for this. So big M is equal to 115 mol divided by 14 liters. So if we have our calculator out, we're going to put our 115 in first. So 115, 3 sig figs divided by 14, 2 sig figs, we'll see we get 8.2142857. We'll count over 1, 2, 1 won't round it up, so we're going to have 8.2 big M here, which stands for mole over liter. Now our next one says how many moles would be in 2.5 liter of solution if you have 0.67 molarity. So big M is equal to moles divided by liter. So we actually have 0.67 big M is equal to X for mole over 2.5 liters. So we can set it up with a 1 over top and then cross multiply it. So we're going to have X equals 0.67 times 2.5. And we see we get 1.675. We have 2 sig figs here, 2 sig figs here. So count over 1, 2, 7 rounds it up. So we'll have 1.7 mole for this solution. Okay, our final one, we have our dilution equation, which means we have our starting and our final. How many milliliters? That's going to be my V1 of 5 molar, that's my M1, would be needed to dilute, that's my V2, for my M2. So if we start plugging it in, we're going to see that we have M1, V1, M2, V2. So we're going to put our 5 here, our X, we're going to put our 2.2 here, and our 15. So we're going to have 5X equals 2.2 times 15 is going to be 33. So we're going to divide both sides by 5. So 33 divided by 5 gives us 6.6. And we're going to see it's 6.6 milliliters. Now our final question says that if we had that 6.6 milliliters in the last problem, how much water would you need to dilute this? So your final is 15. We need to subtract. So 15 minus 6.6 would give us what? 8.4 milliliters of water. So remember, we're going to make our beaker here. We're trying to get to 15 milliliters. 6.6 of it is of the concentrated 5 molar, then that 8.4 in the middle would make up that water there. So this takes us through our assignment on our Peardeck from today's lesson. Thanks for watching.